Hey guys, welcome to part 2 of object-oriented programming in Java. In this video we will be covering interfaces. If you haven't seen the first video, you may want to go back and quickly view that, as we will be continuing with the code we developed in that video. If not, you can take a look at the GitHub account, the link is down below, and the completed code is all up on that account. So before we get into interfaces, I'm just going to quickly touch on inheritance in general. If we take this test page object, as I showed last time, if we go dot and take a look at the methods on this object, we can see that there's some extra methods here we did not write. So how is that? Because when we take a look at this page class, these methods aren't here. So what's actually going on is there's basically a parent object class, and it has all these methods. And when you create an instance of a class, it's almost like that object is a child of the parent object class, and that object has a set of methods. And when we call the, say, toString method on this object, we're actually calling the toString method on the parent object, which is very nice because it stops you from having to rewrite so much code. So let's add some more methods to this page, but let's actually not type any methods. How are we going to do this? Well, we're going to use the extends keyword. This is how we add parent objects to a class. So let's go up here and type extends after the class name and give it another class, let's say ArrayList, and then give it string just to keep the code error-free. Now, when we create a page object, we're now actually going to have an object that is a child object of an ArrayList object. That means all methods that ArrayList has can now be called on the page object. Let's just quickly demonstrate this. If I come to test page, I go test page dot, I can now go add all, clear, clone, contains, all these methods that you would normally be able to do on an array list, you can now do on page. So if you want to think about it like this, a page has a integer x, it has a integer y. Page is an array list. That's the main difference. It's the difference between has a and is a. When you extend, page becomes another type. When you add a field, page gets some other types. Let's talk about the specifics of extending. In Java, there is no multiple inheritance. Now, what do I mean by this? I mean that in Java, you can only extend one class. I cannot come over here and try and extend big double. That doesn't work. That's because it only allows each class to extend once. So how does this apply to interfaces? Well, to demonstrate this, let's first create an interface. We can create an interface the exact same way we would create a class, by coming over here, going right-click, New Interface. Now, a nice naming convention that I like for writing interfaces is that when you start an interface name, I always like to start it with a capital I. So this makes it very easy to tell when you look in the Package Explorer what is an interface and what is a class. So this is going to be an interface for a page, so we're going to call it iPage. Now you will note that an interface is just a .java file. There's really no difference between an interface and a class. The only noticeable thing is that here it says interface, where in a class it says class. So if you create an interface and realize you want it to be a class, you can just change this to class. Or if you have a class and you realize you want it to be an interface, you can just change it to interface, and everything continues to work. So how do we actually write an interface? Well, an interface you can sort of think of as the rules of a class. Now, what do I mean by this? I mean that an interface only ever defines what a class has. It never defines how a class does something. So in page, you will see there's a getX and getY method. So in the interface, I can declare public int get x, and then semicolon. Here I've declared that there will be a method getX for everything that uses an I page. And I can write another one, public int getY, semicolon. Now I've said that everything that's a page will have a getX and a getY. I've not said what getX or getY does. All I've said is that there will be a method that is public, that returns int, that's called getX, that takes no arguments. That's it. If I tried to write a body to it, I can't, because it's an interface. You cannot write bodies of methods in an interface. So let's go and use this. So just like we did when we extended ArrayList, we can now inherit methods from an interface. In Java, when you want to inherit methods from an interface, you use the keyword implements. And now we just type IPage, and we're done. So implements and extends, there isn't really any difference, except that extends only applies for classes and implements only applies for interfaces. Other than that, they basically do the same thing. Now, if we take a look at this class, not much has actually changed, and that's because these getX and getY methods were already here. So let's go and create some more methods in this I page. We're going to create one, public object get data, public int get data size. So we've just declared two new methods. One that is public, takes an object, or returns an object and takes no parameters. One that's public, returns an integer and takes no parameters. And if we go and look at page, we now have an error. When looking at this error, it says add unimplemented method. So if you click on this, Eclipse will automatically add these new methods. So what's actually happened is that IPage, when we implemented it, enforces a rule on this entire class that it must have a getX method, a getY method, a getData method, and a getDataSize method. If we were to try and change getDataSize to take a string, or to return a string, it wouldn't work. There would be an error. If we would try to give it an integer, it wouldn't work. There's an error, because we have told it that there's going to be a method that takes no integers, no strings, no parameters at all, returns an integer, and is called getDataSize. If we wanted it to take an integer, we would have to come to IPage and declare that this method takes an integer. Now we can give it an integer in that class. But we don't want to. So let's get rid of that. And for simplicity's sakes, while we're at it, we're going to remove this extending ArrayList because it's not needed. So that is basically it for what you do with an interface. Now, let's showcase why you would use an interface. To do this, I'm going to create another class. I'm going to come over here and go New Class, and I'm going to call this Blocks Page. Now, if you remember from the first video, the purpose of this project is to represent the data that could be held in a book. Now, books have many different types of pages, and there's always going to be different types of data on the page, and you would never know really what kind of data is going to be on the page. And depending exactly on what type of data is on the page, you might want to use a different page object to store that data. If you have a book that has tons of text on almost every single page, but every 105th page there is 3 massive pictures, you're going to want to use a different class to store that data. So we've created a new page, blocks page, that's just going to be almost exactly the same as the original page, but stores slightly different types of data. So how are we going to do this? Well, first thing is we're going to implement IPage. And let's look at what this does. As before, it enforces the rules that I must have these methods. That's great, because now blocks page and page will have a set of methods that are similar to in both. This means I can use both data types in almost the same way. Why would I do this? Well, if I come back to this main method, I can make an array of pages. That's no problem. Test new array equals new page. Sorry about that. There we go. Array of pages. But as I said before, maybe not all pages in the book are going to have text all over them. Maybe some of them are going to have huge pictures on it. Well, I still want those pages to be in my array of pages for this book. And I still want certain methods to be able to be called on those pages. I still want to be able to get the page number and get the dimensions of the page. I still want to be able to get the data from the page. It just might not be the exact same format of data. So what I can do is, instead of making an array of pages, I can make an array of I pages. And this is cool, because now I can say test new array at 0 equals new page, 0 tab 0, just for the sake, and at 1 equals new blocks page. And I now have an array with two distinct different types of classes, but they both share methods. So I can now iterate over this array, calling some of those shared methods to do whatever it is I need to do. But when I need to do separate things specific for those individual pages, I can still do it. It's fine. And that makes programming, especially big projects, super easy. I think I'm going to leave it here, guys. I was going to make this longer and get into abstract classes as well, but this video is already going to be a decent length, and I don't want to make it too long and overwhelming and just fire everything all at once. So I'm going to try and split this up, and this seems like a good place to pause for a second. So that is basically the beginning of interfaces. We will be going more into this in the next video when we do abstract classes. So I'll see you then.